Describing data. Data is a collection of actual observation or score in a survey or an experiment. Now we will see about types of data. Based on the data, it may be descriptive or it may be a numerical value. So based on that, we have two categories of data: qualitative data and quantitative data. Qualitative data contains categorical variables. If suppose if it is a quantitative data, it contains a numerical value. So based on the qualitative data, it is again classified into nominal and ordinal. Quantitative data can be classified into discrete and continuous. Qualitative data means there is no number in a data. It cannot be measured. For example, smell, taste, or color they cannot be measured, but it contains some descriptive type of data. It may be classified into nominal and ordinal data. So nominal data means it is used for naming variable base and it has no numerical value. Nominal data is nothing but it is a collection of value which contains non-numerical value. It does not have any order. For example, colors, taste, language. In a language we will know Hindi, English, Marathi. These are the languages. The data can be Hindi, English, like that. Next one is ordinal data. Ordinal data is defined as a qualitative data which has some order. The order may be first rank, second rank, or it may be a low, medium, high values. So we can easily sort the clothing brand size according to their name tag in the order of small, medium, large. This one is the example for ordinal data. Then next one is quantitative data. Quantitative data are numbers. So makeup of numbers are makeup of quantitative data. Example, we can have a volume, height, width, length, temperature are the example of quantitative data. The next one is discrete data. Discrete data is counted, but it can only have a certain value. For example, when we roll one die, we obtain 1, 2, 3 or 6 as a discrete data. The total number of students enrolled in a class is a discrete data. The number of children in your house is a discrete data. That is, it has certain value, but it is counted. We can count the values. Next one is continuous. Continuous data is measured. The value can be anything, but it within the range. Example, it is a continuous data is a set of numbers, can have any decimal or fractional value, height, width, like that, etc. If the newborn baby weight, it may be some fixed range. It cannot be extended up to 5 kg. So these are considered as a continuous data. So next one is interval scale. Values that do not have natural zero are referred to as interval scale. So temperature, pH and credit score are the example for interval scale. Then next one is ratio scale. Ratio scale is a set of values that have a natural zero. The one thing it is differ from interval scale is it have a natural zero, but interval scale does not have a natural zero. Example, 0 kg. If a weight of a person is 0 kg, it does not it's a notable absence of weight. So next one is here the example. The age, family size, academic major and the IQ score, net worth. This is the exercise problem. So for that we have a solution for each type of data. Then we will move on to frequency distribution for quantitative data. The frequency distribution is a collection of observation are produced by sorting observation into and showing their frequency of occurrence of each item. The quiz mark obtained by a student and the number of students who got 15, 17, 20, 41, 14 are the table displayed in this example. So the quiz mark 15 is obtained by 2 students, 17 is obtained by 3 students, 20 is obtained by 3 students, 14 is obtained by 2 students. Some frequency distributions are categorized, that is grouped frequency, ungrouped frequency and relative frequency, then cumulative frequencies. So first we will see about grouped frequency. Grouped frequency means arrange the large number of observation or data. We use grouped frequency table. So in this the class intervals to the tally the frequency for the data belong to that particular class interval. For example, if the 20 students are got 20 students marks are shown in the table, so we can group based on the test mark. We can range from, for example, 0 to 5, 6 to 10 up to 20. So 20 different marks are from 0 to 20 different marks are obtained by 20 students. So the frequency table contains the group of each group. It will make we can make the group based on their mark and also the second column indicates the number of students, that is frequency of 0 to 5 marks obtained by 3 students, the 6 to 10 marks obtained by 4 students. Likewise we can create the table. One is for marks, the another one column is indicates the frequency. Then next one is ungrouped frequency, means there is no need of previous one. We can group the frequency range from the given data. If the ungrouped frequency means we no need to group the data. We can directly obtained the marks obtained by the students and the number of students got the particular mark. For example, 5 students obtained 5 marks obtained by 3 students. 10 marks, the total test score 10 is obtained by 4 students. So the total score 15 is obtained by 5 students. This is the example for ungrouped frequency. Next one is relative frequency. Relative frequency means the given grouped first table indicates the grouped frequency and the grouped data and the frequency of each and every group. From those group we can find out the relative frequency. Relative frequency means we can find the total number of frequencies as a sum of f. The summation f is here the example we have a summation f is 53. Then we can use the formula, that is relative frequency is divide the frequency for each class by the total number of the entire set distribution. So total distribution summation f is equal to 53. So for each and every frequency we can find out the relative frequency by dividing the particular group frequency by total number of frequencies. So for example, 1 divided by 53, 0 divided by 53, 3 divided by 53, up to 3 divided by 53 we can get the relative frequency and the summation of relative frequency. Then next one is the cumulative frequency. Cumulative frequency is calculated from the relative frequency. From the frequency distribution table. So frequency distribution, from the frequency distribution we can have frequency of each group and the total frequency. So from last value of the frequency is 3, the previous one is 1. So we can add the last frequency with the previous one. So 3 plus 1 is 4 Likewise, we can cumulate the frequency from the least one to highest one. So last one is 3. 3 is cumulative frequency also we can go with 3. The next step is 3 plus 1 is 4. Then the next step is 4 plus 17 is 21. Then the next step is 12 plus 21 is 33. Likewise, we can add the frequency of cumulative the frequency from the 130 to 139 group to 240 to 249 group. So we can get the cumulative frequency as the sum of the frequency 53. If the 53 is obtained, then your calculation of cumulative frequency is correct. Then next one is cumulative percentage. Cumulative percentage is calculated from the cumulative frequency. So cumulative frequency, for example, 3 divided by 53 into 100. So we can calculate the cumulative frequency percentage. So obtained the cumulative frequency value into 100. So 100 percentage is calculated as a percentage of cumulative frequency. Thank you.